So, coming to the next question, mechanical properties of solids. The maximum elongation of a steel wire, you are asked to find maximum elongation. Maximum elongation. Maximum elongation in a steel wire. Of 1 meter length, if elastic limit of the steel, here the elastic limit is given, you can apply Hooke's law. Within the elastic limit, we can apply Hooke's law. If the elastic limit of the steel and its Young's modulus are 8 into 10 power 8 and 2 into 10 power 11, we are asked to find maximum elongation. Young's modulus Y, stress by strain, we know that. So, Y is equal to F into L by A into delta L, we have this relation. Following this, maximum elongation delta L max, delta L is coming to this side, F by A is in the numerator divided by Y and L is there. We are rearranging this equation. Rearranging like this, here in order to get maximum elongation, whatever this stress force by area, that stress you can take elastic limit. That is the elastic limit. The stress corresponding to elastic limit is 8 into 10 power 8. So, 8 into 10 power 8 and the length of the wire is given 1 meter 1 and Young's modulus is 2 into 10 power 11. So, this 2 4 and you will get 4 into 10 power minus 3 meters. So, it is 4 millimeters, that is it. So, our answer is third option. Next conceptual question, simple question based on polarization. An unpolarized light beam strikes a glass surface, that means a denser surface, a denser medium surface, particularly at Brewster's angle. We know Brewster's angle, that is also called as polarizing angle or angle of polarization. What is the meaning of Brewster's angle? The angle of incidence of the unpolarized light at which reflected light completely polarized, refracted light partially polarized, right. So, in the definition of Brewster's angle itself, we can find the concept. See, this is the interface separating the two media, this side air like rarer medium and this side glass like denser medium. Now, the light ray is incident at an angle, this is a particular angle IP, we are taking it as polarizing angle. For this polarizing angle, when you see the reflected light, incident light unpolarized, we can represent unpolarized light with dot and arrow vibrations. Reflected light only at this angle is completely polarized with only dot vibrations. Dot vibrations means parallel to that glass surface. See, this is the glass surface. When the glass surface is like this, light is incident on it and reflected light is like this, and the vibrations in that reflected light are into the plane. Into the plane means dot. Okay, these are only dot vibrations representing only completely polarized light. And when you see the refracted light, this is the refracted light. In this refracted light, you can see both dot and arrow vibrations. So, this refracted light is partially polarized. Reflected light is completely polarized with dot vibrations. So, if you see options, both the reflected and refracted light will be completely polarized, that is wrong. The reflected light will be completely polarized, but the refracted light will be partially polarized, that is the correct one at Brewster's angle. If the angle is not Brewster's angle, other than Brewster's angle, both reflected light and refracted light are partially polarized. Okay. Next question taken from magnetism and matter, particularly vibration magnetometer, oscillating magnet in a uniform magnetic field. That is the principle in vibration magnetometer. Vibration magnetometer is there in magnetism. That is an oscillating bar magnet, an oscillating bar magnet in uniform magnetic field. So, it is an oscillator. Based on that oscillator, it is given in a uniform magnetic field of 0.049 Tesla, that is capital B. Capital B. A magnetic needle performs 20 complete oscillations in a time of 5 seconds. The moment of inertia of the needle, that is 9.8 in 10 power minus 6. If the magnitude of magnetic moment of the needle x into 10 power minus 5, x into 10 power minus 5 ampere meter square, then the value of x. So, in this situation, what is the time taken for one oscillation? That is the time period. The time period for an oscillating bar magnet in the uniform magnetic field, 2 pi into square root of I divided by mb. I is moment of inertia, capital M is magnetic moment of the bar magnet, B uniform magnetic field applied, and here the time is time period. Now see, 20 complete oscillations in 5 seconds. 20 oscillations, so time taken is 5 seconds. For one oscillation, 5 divided by 20. For one oscillation time taken, 5 by 20 is equal to 2 pi into square root of that moment of inertia 9.8 into 10 power minus 6 followed by what next, m, magnetic moment x into 10 power minus 5, x into 10 power minus 5, and b value is given 0.049. So, here you have to find this x. So, simplification you will get the answer. On simplification you will find the answer, you will get 1280 pi square. This 5 4 times, squaring both sides, 1 by 16, 4 pi square, 9.8 into 10 power minus 6 by x into 10 power minus 5. Here you write 0.049 as 4.9 into 10 power minus 2, so that this 4.9 in 9.8 2 times, you will get x. 16 comes to this side, 16 4s are 64, 64 pi square into 2 into this is 10 power minus 7 denominator, 10 power minus 7 denominator, 10 power minus 6 numerator, you will get 10. So, finally, you will get 1280 pi square. This is the value of x. Now, the first question from ray optics. This is the first question from ray optics. A light ray enters through a right angled prism. That is important here, right angled. Right angle means angle of the prism you have to consider 90 degrees. At a point P, see the figure, at a point P, angle of incidence is 30, that is I1, first angle of incidence. As shown in the figure, it travels through the prism parallel to base. Light ray is traveling parallel to the base and emerges along the face AB, grazing the surface. Incident on the first surface at an angle 30 degrees, and from the second refracting surface, it is grazing the surface, so that angle of emergence here 90 degrees, right. The refractive index of the prism, you are asked to find refractive index of the material of the prism, right. Now see, this A angle of the prism is sum of the two angles of refraction, R1 plus R2. In that R1 and R2, A is equal to, that is 90 degrees, is equal to R1 we do not know, here R1. In the diagram, that R1 is here, this is R1, right, and this is R2. this is I2, I2 is 90 degrees. For 90 degrees I2 at the second surface for grazing emergence, the angle of incidence in the denser medium must be equal to C, R2 must be equal to C. So, what I write here, R1 plus C, R1 plus C, so that R1 is equal to 90 minus C, R1 is equal to 90 minus C. C, this is R1, right. To find the refractive index, mu at the first surface sin I1, at the first surface sin I1 by sin R1, sin I1 by sin R1, there mu is equal to sin 30 degree, given the angle of incidence on the first surface as 30 degrees, and by sin R1 means now you can write 90 minus C. So, this is mu, sin 90 minus C comes to this side as cos C, cos C is equal to 1 by 2, sin that is 1 by 2. Now, see this mu into cos C we can write 1 minus sin square C is equal to 1 by 2. Mu into square root of 1 minus sin square C. From the definition of critical angle, we have the relation mu is equal to 1 by sin C. Mu is equal to 1 by sin C. So, whatever sin C, whatever that sin C, I can write 1 by mu. I can write 1 by mu. This is sin C, I write it as 1 by mu. Substitute that 1 by mu. So, you will get 1 by mu square here, which is 1 by 2, which is equal to 1 by 2. Simplification, square root of mu square minus 1. See, taking LCM mu square minus 1 by mu square coming out of the root, it becomes mu. In the denominator, mu gets cancelled, and you have square root of mu square minus 1 is equal to 1 by 2. So, mu square minus 1, 1 by 4. Mu square is equal to minus 1 comes to this side, 1 by 4 plus 1, you will get 5 by 4. So, mu is equal to root 5 whole by 2. So, root over 5 whole by 2, this one. Next one, related to rigid body. The moment of inertia of a thin rod about an axis passing through its midpoint and perpendicular to the rod is 2400 grams centimeter square. The length of the 400 gram rod is nearly. So, simple one. Moment of inertia of a uniform rod about an axis passing through its midpoint and perpendicular to its length will be ml square by 12. That is the formula you are having. In this, you are given moment of inertia as of 2400 is equal to mass 400 grams, no need to convert. It is in gram centimeter square, which one? Moment of inertia. And mass is in grams, no need to convert, into L square by 12. See, this 0, 0 gets cancelled. 4 in the 6 times. So, L square will get 72. L square value 72. So, L is equal to root 72. It is around 8.5 centimeters. You will get this one, second option. This is the third question from the electric potential and capacitors. In capacitors, this is the first question. In the following circuit, the equivalent capacitance between A and B. You are asked to find the equivalent capacitance between A and B. If you see the circuit, it is nothing but Wheatstone's bridge. Wheatstone's bridge with capacitors P, Q, R, S. In between middle capacitor is there, it is like galvanometer. Under balance condition, P by Q is equal to R by S. Okay. So, if you see that figure, this is P, this is Q, this is R, and this is S. So, whatever the condition for Wheatstone's bridge, P by Q is equal to R by S is balance condition satisfied. That balance condition is satisfied. When the balance condition is satisfied, we can remove the middle capacitor. When balance is achieved, potential difference across this middle capacitor becomes 0. So, we can remove this. When we remove this, these two are in series and these two are in series. These two are in series means in series capacitors, identical, two capacitors identical in series, C by 2, 2 by 2, you will get 1 microfarad. In the same way, these two identical 2 microfarad each in series, effective 1 microfarad. 1 microfarad parallel. So, parallel means finally you will get effective capacity between A and B. Effective capacity in between A and B means 1 plus 1, you will get 2 microfarad. One thing you can easily remember, in Wheatstone's bridge network, if all the values are same, P, Q, R, S values are same. If all the values are same, your answer will be the same. All are 2 microfarad means effective capacity is 2 microfarad. All are 10 microfarad means effective capacity will be 10 microfarad. So, when the Wheatstone's bridge is balanced with identical capacitors, even for the resistors also, all are same means answer is the same. Next question, rotation. Actually, there is a discussion going on about this question. It is a rolling motion based question. This question is related to rolling motion. As the rolling motion is not mentioned in the NTA syllabus for NEET, so everybody thinking that it is out of syllabus, but there is ambiguity, right? Anyhow, we can answer based on the rotation itself. We can answer this question based on the rotation. See, a wheel of bullock cart is rolling on a level road. It is rolling on a level road. Rolling. If its linear speed is v in the direction shown, that means the center of mass. The center of mass of this wheel is having linear speed of v. Then which one of the following options are correct about P and Q points? P is the topmost point and Q is the lowest point. Okay. In this rolling, confining to only rotation. In this rolling, confining only to rotation. That means treating this as rotation about the point of contact. See, Q is the point of contact. At this instant, we can assume that wheel is in rotation about this point of contact. Okay. In such a case, this center point is at the distance of r, say radius. Okay. Center point is a c. So, the velocity, linear velocity Vc, that is actually given v, that is equal to r omega, when omega is the angular velocity, right? By taking omega angular velocity for the wheel about the point of contact, at that instant, at that moment, for the center v is equal to r omega. Okay. and when you take the highest point, when we take the highest point, right, that is P, velocity at the point P, that is again r omega, that is again the formula is r omega, but the distance is 2r, not r. So, we write 2r omega. That means this r omega v 2v. So, velocity of the topmost point is 2v, velocity of the center is v, velocity of the topmost point is 2v, and the lowest point when you see vq, velocity at q. There is no distance for this point because we are taking about that point itself. Okay. So, 0 into omega 0. So, what happened? Velocity at the highest point is, topmost point is 2v, velocity at the point of contact q is 0. See the options. Both the points P and Q move with equal speed, that is wrong. Point P has 0 speed, that is wrong. Point P moves slower than point Q, that is also wrong. Point P moves faster than point Q, that is correct. Point P speed is 2v, point Q 0 speed. It is the point of contact. So, actually this is rolling. We can understand the same rolling as rotation about the point of contact, about the point of contact rotation. So, whether they give add score or not, we do not know. Next, we are given with a graph. There is a graph drawn between 1 by lambda square values and kinetic energy E. Lambda is the de Broglie wavelength. We know de Broglie wavelength, how it is related. De Broglie wavelength, how it is related with the energy. De Broglie wavelength, how it is related with the energy. De Broglie wavelength lambda is actually h by p. P is the linear momentum. That is h by square root of 2m into kinetic energy. There is a relation we are having. Squaring both sides, you will get lambda square h by 2m. That kinetic energy is mentioned as capital E, right. So, capital E and lambda, how they are related means E is equal to h by 2m lambda square, right. So, from this E proportional to 1 by lambda square. In the graph, along x direction energy, along y direction 1 by lambda square. See, along x direction energy, along y direction 1 by lambda square. So, you can assume this one as x proportional to y. X proportional to y means linear relation. Linear relation. Linear relation means that is a straight line. That is a straight line passing through origin. That is a straight line passing through origin. So, no other chance. Generally, for this type of question, students, what they feel, just by looking at the question, immediately what they think, E and lambda square. E and lambda square, non-linear. Non-linear means curve. Curve, that is like parabola, that is like parabola, they think like that, okay. But actually they are asking between E and 1 by lambda square. It is not the graph in between E and lambda square, it is the graph between E and 1 by lambda square. So, along y direction, y means 1 by lambda square, that is why it is a straight line passing through origin. This is a basic understanding of the graphs. So, that is the end of section A. Now, the section B. In the section B, you can see question from ray optics related to optical instruments, telescope. A small telescope has an objective of focal length 140 centimeter. This is 140 centimeter. FO, objective focal length FO 140, and eyepiece has a focal length of 5 centimeter FE. Magnifying power magnifying power. FO by FE, general relation we have. Simple. So, this is 140 divided by 5.05. You will get 28. 28. Simple. Why we are taking this equation FO by FE? Because this telescope is adjusted to distant object. See, distant object. That means telescope is a normal adjustment. Relaxed vision. Relaxed vision. Now coming to the next question. It is related to thermal properties. I think till now, in these 36 questions, we did not see any question related to thermal properties of matter. This is the first question in thermal properties of matter. The following graph represents the temperature versus volume TV curves of an ideal gas at 3 pressures P1, P2, P3 compared with those of Charles' law represented as a dotted lines. Dotted lines are lines passing through origin. Dotted lines are the lines passing through origin, but there is slight deviation. We know that. Slight deviation from the gas laws. So, that is why we are getting the curves. Right. Then the correct relation for the pressures. Here you have to follow that ideal gas equation. Ideal gas equation PV is equal to nRT, we know that. So, pressure P is equal to nRT by V. Here N and R are constants. So, pressure is directly proportional to T by V. Pressure is directly proportional to T by V means in the graph if you see this is TV graph, TV graph. So, in the TV graph slope of TV graph is equal to T by V. That means pressure is directly proportional to slope. Pressure is directly proportional to slope. More is the slope, more is the pressure. More is the slope, more is the pressure. So, when you see P1, P2, P3, for this P1 more slope, next P2, next P3. So, when you follow the order, P1 greater than P2, which is greater than P3. So, the highest pressure is P1 and the least pressure is P3. See that. P1 greater than P2 greater than P3, second option. Just a minute, we change the background so that we can see clearly. This background may not be clear, may not be visible properly. We will change it to black so that you can see clearly. Now, see that next question, this is 38th question related to oscillations. If the mass of the bob in a simple pendulum is increased to thrice its original mass, mass of the bob is increased to thrice and length is made half. Question repeated, I think. First line is repeated again. The new time period of oscillations is x by 2, its original time period, then value of x. When we see the time period of a simple pendulum, T is equal to 2 pi into square root of L by G. From this expression, time period is dependent on length of the pendulum, time period is dependent on acceleration due to gravity, that means the place where that pendulum is oscillating. There is no mass of the bob in the time period expression, independent of mass. There is no mass of the bob in the expression of the time period. So, time period is independent of mass, that is the law of masses in case of simple pendulum. So, what we can consider here, T proportional to root L, T proportional to root L, because there is no variation in G given. So, T proportional to root L means, now here what happened, length is made half, length is made half. If I write the relation T2 by T1 is equal to square root of L2 by L1, it is given the new time period of oscillation x by 2 times the original time period. Original time period is T1, see, x by 2 times T1 is T2, x by 2 times T1 is T2 by T1 is equal to square root of L by 2 by L, length is made half, T1 gets cancelled, x by 2 is equal to 1 by root 2, you will get x value 2 by root 2. So, x is equal to root 2, that x value is root 2. Next question related to current electricity. Two heaters A and B have powers rating 1 kilowatt and 2 kilowatt respectively. Those two are first connected in series and then in parallel to a fixed power source. The ratio of the power outputs are for these two cases. Okay. When heaters are electrical devices, when connected in series, we have the expression if Ps is the power of the combination in series, that is actually 1 by P1 plus 1 by P2. In series, the relation for the powers, when P1, P2 are individual powers. In parallel combination, it is P1 plus P2 effective power. There is a difference. Okay. Now, this 1 by Ps with the two heaters, 1 by 1 plus 1 by 2, this will be 3 by 2. This is 3 by 2. That means power in the series combination becomes 2 by 3. This is the power, kilowatts, right? In parallel combination, just addition. So, 1 plus 2, you will get 3 kilowatts. Now, you have to find the ratio. You have to find the ratio between these two, power in series by power in parallel combination. That is 2 by 3 by 3. You will get 2 by 9. Next question, related to units and dimensions. A force defined by F is equal to alpha t square plus beta t acts on a particle at a given time t, the factor which is dimensionless. We can do it in two ways. Directly finding alpha beta, verification. Okay. Now see, you are given F is equal to alpha t square plus beta t. Left hand side is force, right hand side total must be force, that is the principle of homogeneity, we know. Left hand side must be equal to right hand side dimensionally. So, dimensionally they should be the same, means sum of these two terms must be representing force. So, alpha t square plus beta t force means alpha t square must represent force dimensionally and beta t also represents the force dimensionally. So, that alpha is equal to force means ml t power minus 2 divided by t square, you will get ml t power minus 4, and beta is equal to ml t power minus 2 by t, you will get ml t power minus 3. So, you are getting beta like this and you are getting alpha like this. Among the given options, which is dimensionless? Which is the dimensionless? See the first option. First you verify the first one, alpha, beta, t. Multiply alpha and beta. Multiply alpha and beta. Multiplication of alpha, beta, you cannot get m power 0, m square, l square. So, that cannot be the answer. Alpha, beta by t, that is also not possible. Alpha, beta, you are multiplying again, m and m square, l into l square. So, it cannot be m power 0, l power 0, t power 0. Dimensionless. Dimensionless means you have to get m power 0, l power 0, t power 0. You are not getting that with the first two options. And when we see the third one, beta t by alpha. See, beta t by alpha. Check the third one, beta t by alpha. Beta means m l t power minus 3 into t by alpha. Alpha m l t power minus 4. Okay, what you will get? ml cancel, t power minus 2 there, minus 4 goes to numerator, you will get t square here. It is also not possible. Third one also not possible. So, the possibility is only fourth one, alpha t by beta. That means ml t power minus 4 into t by ml t power minus 3. Okay, see this t power minus 4, t power minus 3 total gets cancelled and it becomes m power 0, l power 0, t power 0. So, fourth one is possible. Another question related to capacitors. I think this is the fourth one, electric potential and capacitor chapter. If the particles of a parallel, if the plates of a parallel plate capacitor connected to a battery are moved close to each other. This is a parallel plate capacitor. Between the plates, distance of separation is d. Between the plates, distance of separation is d. In such a case, capacity of the parallel plate capacitor epsilon naught a by d. What is given? If the plates of a parallel plate capacitor connected to the battery are moved close to each other, that means this distance is decreasing. This distance is decreasing. When the distance decreases, capacity has to increase. Capacity has to increase. Here you can see that point. Distance d decreases, capacity increases. And Q is equal to CV, whatever the charge on the plates. Whatever the charge on the plates, that is C into V. It is connected to a fixed battery. It is connected to a fixed battery, potential difference is constant. Fixed battery, potential difference constant. V constant, C increasing. V constant, C increasing, Q increases. Okay, charge increases. See the first option, the charge stored in it increases, that is also correct. Energy stored, what about energy stored? Energy U is equal to half CV square, one of the relation. V fixed constant, C increases, energy increases, energy stored also increases. Ratio of the fourth one, D, ratio of the charge to potential, Q by V. Q by V, Q by V is nothing but C. Q by V is nothing but C. What happened to C? C increasing. C increasing, but in this they are telling it remains the same, that is wrong. Next one is product of charge and voltage, QV. QV, charge increasing, potential remains the same. Okay, this value increases. Q increasing, V constant, total product increases. E correct. A, B, C, E are correct. A, B, C, E are correct. A, B, D is only wrong. D is only wrong. I think that is missing. One part is missing. Energy stored in it. Here it is wrong. Typed wrong. This is typed wrong, it is given decreases. In the question paper it is given decreases, typed wrong. So B is not there. ACE, ACE, last one. Okay, so conceptually you have to be clear, very, very clear. Next question, this is the, I think this is the third question, magnetism matter. An iron bar of length L has magnetic moment capital M. It is bent at the middle of its length such that two arms make an angle 60 degrees with each other, the magnetic moment of the new magnet. This is the bar magnet with north and south poles like this, with length of the magnet as a 2L and magnetic moment capital M, small m into 2L. We write like this. Now it is bent at the midpoint. When it is bent at the midpoint, now that magnet appears like this. This is north pole and this is south pole at the bent at the midpoint, and the angle here is theta. In such a case, what is the new magnetic moment? New magnetic moment M dash is equal to pole strength no change. On bending small m, pole strength of the poles no change. Distance between the poles changes. Here the distance between the poles is 2L. Now the distance between the two poles, that is the length of the magnet. Length of the magnet is different, it is not 2L, it is some 2x. It is some 2x. Okay. Now this small m into 2x we have to write. To write that, draw a perpendicular bisector so that this length becomes x. Okay. This length 2L by 2. When it is straight, it is 2L total. It is bent midpoint. It is bent at the midpoint, so this length is 2L by 2. So there you can see a right angle triangle. See there, this is x, this is 2L by 2, and this angle, this total angle is theta. Half of that angle, theta by 2, write sin theta by 2. Sin theta by 2 is equal to opposite x by 2L by 2, right. So this 2 goes to numerator, 2x, 2L sin theta by 2. So whatever the 2x, you can write 2L sin theta by 2. Small m into 2L is capital M. So capital M sin theta by 2. So that is a new magnetic moment. This is a formula. New magnetic moment capital M dash, M dash is equal to M sin theta by 2. So M dash is equal to M into sin, it is given angle bent 60 degree. So sin 60 by 2, sin 30, M sin 30, you will get M by 2, okay, so M by 2. Okay, we move to the next one. It is a conceptual question. A sheet is placed on a horizontal surface in front of a strong magnetic pole. A sheet is placed in front of a magnet. Suppose this is the sheet. Placed in front of a strong magnet. You can assume a sheet like this. It is placed in front of a strong magnet or magnetic pole. Single pole is not possible, we put a magnet. Strong magnetic pole. A force is needed. A force is needed. From the options you have to follow. Take the options. Hold the sheet if it is a magnetic. Hold the sheet if it is a magnetic. See, when this is the magnetic pole, when this is a strong magnetic pole, if this is a magnetic material, this north pole can induce magnetism in this sheet, induces magnetism. Inducing magnetism means opposite pole is developed. Opposite pole is developed on the side nearer to this inducing pole. This is inducing pole. So, this inducing pole induces opposite pole nearer to it. So, there is attraction. In between the sheet and that north pole, there is attraction. With attraction, this sheet may move towards that. Okay, towards the magnet, towards the pole, the sheet may move. In order to avoid that, we have to hold it. Okay, so the first one is correct. Hold the sheet there if it is non-magnetic. Non-magnetic means there is no influence of the magnetic pole. Nothing will happen. To the sheet, nothing will happen. No need to hold the sheet. So, second one is wrong. Next one, move the sheet away from the pole with uniform velocity if it is conducting. A force is needed to move the sheet. Read combinedly. A force is needed to move the sheet away from the pole with uniform velocity if it is conducting. That is the interesting point. Now see, when you wanted to move this sheet away from the magnet or magnetic pole, what happens? Due to this magnetic pole, whatever the magnetic field linked with this sheet, when you are moving this sheet away from the magnet or magnetic pole, magnetic field linked with the sheet decreases. That means magnetic flux linked with the sheet decreases. When magnetic flux changes with the conducting sheet, there is induced EMF. Or otherwise we can call it as eddy current. Eddy current if it is conducting, it is given conducting, there is a metal. Sheet is given magnetic, non-magnetic, now it is conducting. Conducting sheet means metallic sheet. Inside the metallic sheet what happens? Eddy currents are produced. Those eddy currents are nothing but inside the sheet, eddy currents are produced. These eddy currents develop a magnetic field which opposes the change in flux. Changing flux means decreasing flux when we move away. Okay, decreasing flux has to be increased. That's why, so it becomes difficult to move the sheet away. For that you have to use a force. Okay, so that C is also correct. What is the last one? A force is needed to move the sheet away from the pole with uniform velocity if it is both conducting and non-conducting. That is wrong. Non-conducting, no induced current. Right? AC circuits. This is the first question in AC circuits till now. A 10 microfarad capacitor is connected to a 210 volt 50 hertz source as shown. So, this is a pure capacitor AC circuit. What is the peak current? In this type of circuit, peak current I naught, that is E naught divided by XC, capacitor reactance, that is E naught by 1 by omega C, that we have to write, right. So, peak current is equal to peak voltage into omega C. Omega is 2 pi f into C, 2 pi f into C. Substitute all the values. You are given 210 volts. See, at the source, whatever the value represented like this, it is RMS value. Okay, E RMS is 210 volts, right. Actually, RMS means E naught by root 2. So, E naught means root 2 times E RMS. That means root 2 times 210. So, E naught here root 2 times 210 volts, 2 pi value asked to take 3.14, this is given, and the frequency is given 50 hertz, frequency is mentioned 50 hertz, and the capacity given in the circuit, that is 10 into 10 power minus 6. Okay. On simplification, you will get 0.93 amperes. Now see the next question. This is the previous one. Now the next question. A metallic bar is given. A metallic bar of Young's modulus Y given, coefficient of thermal expansion given, length and area of cross section are given, heated from 0 to 100 given, 100 degrees without expansion or bending. The compressive force, it's a direct problem. Compressive force means F is equal to YA alpha delta T. We are having this relation from thermal stress. From thermal stress, you can find thermal force. YA alpha delta T. Y is given 0.5 into 10 power 11. Area of cross section 10 power minus 3. Alpha is given 10 power minus 5. And temperature difference is 100. Simplify this. So multiple of 5. You will get 50 into 10 power 3 newtons. You will get this one. Simple question. Now see, velocity time graph given. We are given the velocity time graph. We are asked to identify correct acceleration time graph. From velocity time graph, you have to find acceleration time graph. Slope of velocity time graph giving the acceleration. Slope of velocity time graph giving the acceleration. Area of velocity time graph giving the displacement. Area giving displacement, slope giving acceleration. If you see in this velocity time graph given, this is the positive acceleration. This is 0 acceleration. This is negative acceleration. Scale is not mentioned. Scale is not mentioned. So positive, 0, negative. Where we can find that? Simple. See, here you can see a positive acceleration. This is negative acceleration. In between 0 acceleration. Positive, negative, positive, 0, negative. Positive, 0, negative. Here different, different, different. Right? So the possibility is only this one. Straight line means constant slope. Straight line means constant slope. Positive constant, positive slope constant, negative slope constant and 0 slope. Okay? So easily you can identify. Now another question from current electricity, it is Wheatstone's bridge. You are given the Wheatstone's bridge. See all the options. Balance condition we have to check. In which case we have the balance condition. So the next question related to current electricity, Wheatstone's bridge balancing condition. Now see, following the options, if you see the first option, P by Q must be equal to R by S. Okay, there is a condition required for balance. P by Q, 10 by 10 is 1, 15, and here 5 ohms is there, but parallel to shunted with the diode. Diode is in conducting state. Diode is in conducting state means this 5 ohms is short circuited. 5 ohms is not there. 5 ohms is not there. So 5 ohms is not there, so we cannot get the balancing condition. So this is not possible. First option not possible. Second option is there. 5 ohms is in series with the diode. Diode is conducting, but cell is connected reverse. Here the cell is connected reverse terminals. not possible. Okay, diode not conducting. Here 10 10, 10 by 10 is 1 P by Q, R by S means 15 by, you have to get 15. You have to get 15. So, as the diode is conducting, you can assume 10 ohms here. Diode resistance, if you assume 10 ohms, possibility you are checking. So, 5 plus 10, 15. So, there is possibility. Okay. So, this is possible. And here the diode is in reverse bias condition, won't conduct. So, third option is suitable among the given. Okay. Next, another question. This is a theory question in electromagnetic waves. The property which is not of an electromagnetic wave traveling in free space. Electromagnetic waves travel with the speed of light. This is nothing but C, expression for C. That is the expression for C. This is possible. They originate from the charges moving with uniform speed. That is wrong. Electromagnetic waves are generated by accelerated charges. Electromagnetic waves are generated by accelerated charges, not with uniform speed. They are transverse in nature. That is right. They are transverse waves. And the next one, the energy density in electric field is equal to energy density in magnetic field. That is also true. Energy density half epsilon naught E square, half B square by mu naught. These are the energy densities in electric and magnetic fields. They are equal. That is also correct. So, the wrong one. We are asked to identify which is not, odd one out. Second one is odd. Okay. See the next one. The minimum energy required to launch a satellite of mass m from the surface. So, the next question is from gravitation. The minimum energy required to launch a satellite of mass small m from the surface of earth, of mass capital M, radius capital, in a circular orbit and altitude of 2r from the surface of earth. So, you can write this one as a minimum energy is equal to energy at that height minus energy on the surface. Energy at the height means minus gmm by 2 into r plus h minus plus gmm by r, because on the surface of earth it is having only potential energy. In the orbit, potential energy plus kinetic energy, because it is circulating. Common gmm by 2, it is 1 by r minus 1 by 2 into r plus h. H is given 2r. So, gmm by 2 into denominator you will get 3r, numerator 3 into 6r, you will get 6r here. This is 6 minus 1, 5. So, 5 gmm by, I think there is no 2 here, only gmm is common. That is it. You will get 5 gmm by 6r. Last one, final one, is also conceptual question. A parallel plate capacitor is charged by connecting it to a battery through a resistor. If I is the current in the circuit, then the gap in between the plates is related to displacement current. Displacement current of magnitude equal to I flows in a direction opposite to that of I. That is the wrong one. Displacement current of magnitude greater than I flows but can be in any direction. That is wrong. There is no current. Only the possible thing is displacement current of magnitude equal to I flows in the same direction as I. That is it. Conduction current and displacement current are in the same direction. Conduction current and displacement current are in the same direction. Okay. This is conduction current. This is displacement current. Both are in the same direction. So, that is about NEET paper 2024. Already in the last video, we have given the weightage for this paper. Once again, you can see how the weightage in the first year syllabus and in the second year syllabus, how the chapters weightage, everything you can see. this information, this video is quite useful for incoming second year students and also for the repeaters, okay. How many numerical questions given in the first year and the second year, how many conceptual questions are given in the first year and second year, and last year also comparison, paper level how it is, how many easy questions, how many medium questions, difficult questions, first year, second year, everything you can see here, okay. So that is the end of our video, right. So for the next video we come up with some new topics, okay. Thank you.